What is up, guys? It is Barry Michael Doyle, and I'm back with another video. Yes, I didn't give up after just one video. I'm actually back, and I'm going to try and record regularly. Your comments really help. I really appreciate them. They help me decide what to talk about, because it's more fun to talk about TypeScript and actually tell you what's happening when you guys are actually asking me questions than to just run through things without any feedback. So yeah, let's hop into it. Before I get started, I got a really cool message from Loik van der Westhuizen. He's one of my friends from back home, but nobody knows that I don't live where I grew up in. But yeah, he's one of my friends. He popped me a message saying, if TypeScript is better than JavaScript and easy to learn if you know JavaScript, then why is JavaScript still used? Well, that's a really good question. So congrats on asking a great question. Much appreciated. So basically, most people don't use TypeScript because they don't know about TypeScript. JavaScript is obviously a lot more common. And as I mentioned in the last video, TypeScript is a superset of JavaScript, which means you've got JavaScript on its own, but then you've got TypeScript, which is JavaScript on steroids. It's JavaScript with a bunch of extra rules. It's what it is. It's what it is in the name. TypeScript is JavaScript with types. So the reason why people use JavaScript is they like the freedom of not setting types to everything. The reason I like TypeScript is because you have all of the normal things in JavaScript, so you don't have to learn anything new in JavaScript. It's just the cool stuff that TypeScript gives you. It makes you write better code. It forces you to tell your functions to have types, you know. It gives you, it's easier to read your functions. I'll explain that actually as we go on. Let's head into CodeSignal. Right, guys, so here we are into CodeSignal. Again, we are back into the arcade, which is over here. And in the intro section where the journey begins, we're going to do the second video today, where my friend Yongyun is. He didn't get very far. Salisbury. I went to school with this guy. He was great at maths. By the way, thanks, Loik, for joining. I really appreciate it. And this guy whose name I can't pronounce. Really, really much appreciated. I got more coins. I got more little coins. So one day I can buy a t-shirt. That would be great. In like 20 years' time. I don't know. So let's hop into the second challenge. And here we have the century from year challenge. Now, as I was saying with the TypeScript stuff, is the cool thing about the types is you get to say that it's expecting a number to be returned. So it's got to return like a number, like 5. You can't return Barry, because then if you run the test right now, okay, the test is going to fail because it's giving the wrong input, but it's also going to give me a type error, which will occur here. It says type Barry is not assignable to type number because Barry is a string and Barry is not a number. So if we made this 5, then the tests would fail because it's the wrong output that's expected, not because it's a string, you know? So here we're saying we're expecting a year to be a number inputted, and we're expecting a number to be returned by the function. And the function is called century from year. See here, the tests, like there's no compilation errors. It was just the test that failed because it was expecting 20, but we gave it 5. So that's how that works. The way you'd use this function was another question I wanted to answer, is if we were going to use this, we'd say a century from year, and then we'd say, I don't know, 2019, and then this would give us the answer. I can't spell answer. There we go. So we'd say, we'd actually set this to a variable. We'd say const answer equals century from year. And then this at the moment, because it doesn't actually do anything with the input, just gives us 5. So answer here would equal, I cannot spell, 5. There we go. That's a comment, by the way, if you don't know in JavaScript. You just do a double slash. You can also do comments with slash star. I cannot type. I really cannot type. And this. So this means I can type stuff here as a comment, but then this is real code. So something will go wrong here because it sees this is a comment, which I can even put into here if I wanted to. But the problem happens is that, yeah, you see, I can put code in here. I could put this before this if I wanted to, and that works. So yeah, this is how you would use the function that we're creating here, just in case you didn't know that already. But yeah, as I was going to say, back to Loic's question, why would you use TypeScript over JavaScript? It just makes you write better code. That's literally it. It forces you to, it's easier to read here that we know year is going to be a number and not a string, and we know it's expecting a number and not a string. So also it's good to name your functions well. And yeah, another thing about TypeScript is it compiles down to regular JavaScript. So the browser itself, I'm using Google Chrome right now, but the browsers, they read JavaScript. They can't read TypeScript. So TypeScript gets turned into JavaScript, basically, in layman's terms. So what ends up happening is TypeScript is just JavaScript, but with a bunch of extra rules, and you get a nice little syntax with it, and it ends up being read as just JavaScript. So it's another reason people just use JavaScript, because you don't have to set up TypeScript. And some people find setting things up difficult, so they just stick with JavaScript. But I've found in bigger applications, it is so nice to use TypeScript because you find errors so much easier, and it's so much easier to read the code. I'll get into it later when we start looking at objects and how we can build TypeScript interfaces. TypeScript is amazing for that. Anyway, let's actually get started with this function. So we have to do a century from year. So the description is given a year, return the century it is in. The first century spans from the year 1 up and including the year 100. The second from the year 101 up and to including the year 200. So basically what it's saying is if you've got 65, then the century would be 1. If you had 165, the century would be 2. If you had 200, the century would still be 2. If you had 201, the century would be 3. It's kind of like if we think about, it's 2019 now, and this is actually the 21st century, if you think about it. Like we are going into 2100. But yeah, so 2019 is the 21st century. Everything in 1990s is like the 20th century. Or even the 1970s is the 20th century. So you kind of get the idea. So it's like, as it mentioned here, from 1 to 100 is 1, from 101 to 200 is 2. So yeah, for the year 1905, the century from year is going to equal 20. That's the plan. And here, if the year is 1700, then we've got that. So how are we going to calculate this? Actually, before getting started, I just noticed it's worth noting that the guaranteed constraints is the year will be equal to 1 or bigger than 1 up until 2005. So we don't have to worry about negative numbers, which is quite helpful because you're not going to get the negative first century or the negative third century. So that's useful to know that we've got these guaranteed constraints. So we don't have to code around that. So let's bear that in mind as we get started. So we could use some cool math.round stuff, but let's pretend you're doing an interview. They won't really like it if you returned math.round stuff for this. So you could have done math.round, and you would have done the year divided by 100, and you would round it up. I actually can't remember the math.round functions right now, but that's just me being terrible. So what we first want to do is check if the year is smaller or equal to 100, because this is that useful case when you get it's the first century. So this will return 1. Now the next case we want to say is if the year is modulus 100. So what this means is if you say 1000, well, let's do comments. 1000 modulus 100 would be equal to 0. 1000 and, or let's even say 100 modulus 100 is equal to 0. So modulus actually means the remainder. So if we said 102 modulus 100, this percentage sign means modulus, by the way, if you haven't figured out, that would equal 2. So modulus actually gives you the remainder. It's just like if you were to say 5 modulus 2. This would be 5 divided by 2 and give you the remainder. The remainder is 1. So I hope you kind of understand this now. So basically, this means that if if this is the year modulus 100, if it's equal to 0, we use triple equals in JavaScript because we're weird this way, or TypeScript's the same. If this is equal to 0, then we would like to say that the century from this year is the year divided by 100. I said te, it's year. I can't even type right. And then finally, if none of these if case statements happen, then we can just do the normal return, because what we'd normally have to do is say like an else statement, but because our function's working where we return, when you say return, this return means we end the function. So in a return statement, it means you get out of the function. So same here, we get out of the function. So if you haven't got out the function already, you usually say an else. Even in case here, we'd say else if, but we don't have to say else if because you're returning out of the function. So if this is true, then the rest won't run anywhere because we're doing returns. If we wanted to do some sort of like, let's answer, well, just equal 0, and then we say answer equals something, then it would be different. Then we'd use else ifs, but it's nicer to just use if return. So else, if this is not the case, then we would like to say we want to return the year divided by 100 plus 1, and that should give us the right thing. And I don't know if you know bod math, it's like brackets of divide, multiplication, plus, minus. Because this is brackets, this will run first before the plus 1. But even if it's not in brackets, we'll run the divide first before the plus 1, you know. So it's just basic mathematics. If you should know that. You should know this stuff. It's pretty basic. If you don't know this stuff, go learn about orders of operations and you'll probably get it. So now I'm just going to run my tests quickly and make sure everything's working. And this always takes a while. Let's wait and wait and wait and wait. I failed. Something went wrong. Why is this wrong? It's because it's the year divided by 100, and numbers can be floats. So let me fix that quickly. So you know when I said math.round is frowned upon, it's not frowned upon. Well, we're still going to frown upon math.round, but we will do the math.floor. And what this does is it rounds it down. It chops off these fractions basically. So math.floor of, let me write a comment, math.floor of 20.05 would give you just 20, which is nice. So we want to math.floor our two values, so we're going to math.floor this as well, which is cool because now order of operations just makes more sense. And now if we run our tests, everything will actually pass. That's the nice thing about writing unit tests. You can see the expected outcome, which is awesome because you see you did the input, you got the output, and your expected output was this, and the output and expected output matched, and that's what made the test pass. So if you made custom outputs, you could test that as well. You know, you add a custom test, and you just say your input would be 5, and we'd expect our output to be 1. And we write our custom test, because we want if the year is 5, it's the first century. So let's run our test, our little custom test. Testing's great. It's really great. I use it in my actual coding. It stops me from making dumb moves like forgetting the math.floor method, because people make mistakes. But there we go, my custom test passed, which is great. So now I'm going to delete my custom test because I don't need it. All these tests passed, and well, we don't know about the hidden tests. You can unlock these hidden tests by, I don't remember how. You can unlock them if you fail enough times. You can unlock them using your coins. But I want to keep my coins so I can buy a shirt one day. So I'm going to submit this, and then it runs the hidden tests as well. And we will hopefully pass this. And we've got this beautiful, cute little function that takes in a year, which is a number, thanks to TypeScript, and gives us a number. And it gives us the right numbers. There we go, solution has been saved. Let's look at these languages again. Let's go down to TypeScript. And let's find, people give them votes. Guys, you've got to make me the top. Okay, go check my link. My link's in the video to joining. But then go find me and just give me another vote. Make me the best. I want to be the best. In fact, if you vote for me, tell me your name, because you'll be my friend on here. I can just look at friends and I'll give you a vote. I'll vote you up for nothing. Just let me know. Anyway, guys, I hope you enjoyed the video. I hope you've learned something new, and I look forward to catching you in the next one. Please comment below. It helps me make more money on YouTube because more people find the videos, and currently I make like 40 cents a day, which is not really enough for me to buy food on a daily basis. Anyways, I'll catch you guys in the next video. Ciao.